Now that you've got all these properties under your belt, now we're going to do some lots and lots of examples, basically. So you're going to see a command that basically says expand. That means, you know, get rid of all the exponents, get rid of all the products, get rid of all the quotients, write everything out the way that we've been talking about. So when you're doing these problems, sometimes it's not the properties so much that are trouble. What becomes troublesome is the order in which to apply them. So we're going to really walk you kind of through this and make sure you understand what's going on. So for example, this first one, you might say, oh, I can do this because I can just take that 2 and move it out front. Well, you can't, because this 2 just applies to the x, right? This square root just applies to the y. So you can't really take the 2 out because our property only applies if we had, if we had this, we could pull the property out because we could pull the power out because the power would be applied to the entire thing. But as it stands right now, the power only applies to the x. So we've got to split it apart first. So really what we've got is we have x squared times square root of y. So we can pull it apart as a product rule first. So we're going to do the product rule first. And we'll get log base b of x squared plus log base b of the square root of y. Now you can apply the power rule because you can pull the square out. Now the square applies to the whole thing that's going on with the log. So I can write that as 2 log base b of x, and I can write the square root of y as y to the 1/2, and now I can take the 1/2 and pull it out front, log base b of y, like that. Alright? So we're just going to do a ton of these because honestly they've all got like little tricks about them. So say we've got log base 6 of about the cubed root of x over 36 times y to the 4th. Okay? So looking at this, you always want to see, well, what's the overriding function? What's the big function? How do I break down its defenses? I want to go a little bit at a time. So again, I can't take out the 4 because the 4 just applies to the y. I can't take out the cube root because it just applies to the x. So what's the big thing that's going on? What's the big thing that's separating our terms in here? Well, I would say that the big thing that's happening is that we're dividing. So I'm going to first apply the quotient rule because I think that the biggest thing that's happening right now is the fact that we're dividing two things. So I'm going to split this apart using the quotient rule. So I'm going to get log base 6 of that. So the thingy on the top, and then the thingy on the bottom. Okay? Thingy on the top, thingy on the bottom. Alright, now I can maybe rewrite this as x to the 1/3. And what do I have here? Well, I still can't pull out the 4, because the 4 only applies to the y. So since I can't pull out the 4 yet, that means I need to separate this, which is now a product rule. So I'm going to apply the product rule. You don't really have to write out what you're doing, I'm just doing it because I'm weird. The other thing is that since this is a minus sign now, we better be really, really careful. So I'm going to go ahead and put parentheses. So I've got log base 6 of 36 plus log base 6 of y to the 4th. Like that. Okay. So now I'm going to take my 1/3 and pull it out front. So I've got 1/3 log base 6 of x. Now I can distribute my negative sign minus log base 6 of 36 minus log base 6 of y to the 4th. And as I make progress, 1/3 log base 6 of x. Isn't this fun? You're going to be doing like this forever. Minus, and I can say, okay, I've got my 6. So 6 to the what is 36? 6 to the what is 36? I can come in and say, well, 6 squared is 36, so that must be a 2. Minus, and I'll pull my 4 out front. 4 log base 6 and y. And although that might not look a whole lot better, it actually is your answer and could theoretically be a whole lot better depending on what you're actually trying to do. Okay, so let's try something else. This one's kind of a beast. So try, this one's scary because it's got a natural log in it. X to the 6th square root of x squared plus 8 all over x plus 8 to the 7. Alright, again, I can't pull any of the powers out, so I'm going to have to do something about the quotient. So if you're a fantastically studious student, what you might want to do is go ahead and pause this and see if you can get through this problem, because it's not a shoo-in by any means. But you might give it a shot. Okay, and assuming you did that, first thing I'm going to apply is quotient rule. So natural log of the thingy on the top minus the natural log of the thingy on the bottom. And now I can separate the thing that was on the top again. Natural log of x to the 6th plus natural log of the square root of x squared plus 8 minus the natural log of x plus 8 to the 7. Now something you may have noticed is that things, when I'm doing a quotient rule, I actually could have taken this first thing and separated it out into 3 things right off the top. Anything that was right off the bat, anything that was on the top is going to end up having a plus sign in front of it. Anything that was on the bottom is going to end up being subtracted, because it's a quotient rule and a product rule. Anything that's on the top, all getting multiplied together, it's plus. Anything that's on the bottom, you continue to divide by this, divide by that, it's going to have a minus out front. Next step, of course, now is to take the powers and pull them out. 6 plus natural log of x squared plus... Thomas and the Big Big Bridge. See what's really important in life? It's not logarithms, it's Thomas and the Big Big Bridge. Alrighty. So now I can pull these forward. And natural log of x plus 1/2 natural log x squared plus 8 minus 7 natural log x plus 8. What's my next step? That was a trick question. We're done. I need to write it. That was a trick question. We can't separate this. Leave as is. Both this one, as I can spell, I swear, as is. Both of these we want to leave as they are. We can't separate them out. So this right here is actually going to be our final answer for this problem.